Everybody, this is the 2007 free response question number 3. So we've got functions f and g that are differentiable. G is strictly increasing. The table above gives values of the functions and their first derivatives at selected values of x. And we've got the function h is given by this equation right here. So f of g of x minus 6. So part A says explain why there must be a value r between 1 and 3 such that h of r is equal to negative 5. So you'll notice that we're trying to find a specific function value. We're not looking at derivatives yet. We're looking at a specific function value. And so this right here should be an indicator that we're going to need to use the intermediate value theorem. So what we're going to need to do then is we're going to need to see what is h of 1 and what is h of 3, and hopefully negative 5 falls between those two values, because if it does, then IVT can be applied, right? Or then IVT can guarantee the function value. So because f and g are differentiable, h must also be differentiable. So we know we can even use IVT at all because that's the one condition for it. So let's find h of 1. So h of 1 is going to be f of g of 1 minus 6. So that's going to be f of, well, g of 1 is equal to 2 minus 6. And so f of 2 is equal to 9. 9 minus 6 is equal to 3. So h of 1 is equal to 3. And then if we find h of 3, because that's our other endpoint here, right? Then that's going to be f of g of 3 minus 6. So that's going to be f of, let's see, g of 3 is 4 minus 6. And so f of 4 is negative 1 minus 6, which gives us negative 3. And so if we think about it, we can see clearly that this negative 5 that we're hoping to find is going to fall between 3 and negative 7. So IVT guarantees that value for us. So since h of 3 is less than negative 5, which is less than h of 1, and h is continuous, by IVT, so the intermediate value theorem, those are the two conditions, right? The value we're trying to guarantee, this negative 5, has to fall between the two endpoints, and h must be continuous, because we know it must hit that value then. So by IVT, there exists a value r on the interval from 1 to 3 such that h of r is equal to negative 5. So you'll notice the wording of the question actually helps us write the rest of our explanation too, right? There's a value r on the interval such that h of r equals negative 5. That is right here in our explanation then. All right, so let's see, this was worth 2 points. So it was 1 point for finding h of 1 and h of 3, and then 1 point actually for your explanation written out, and of course for using IVT. All right, part B here says explain why there must be a value c on the interval 1 to 3 such that h prime of c is equal to negative 5. So you'll notice the big difference between parts A and B here is that now in part B we're looking at the derivative, which means we're no longer looking at intermediate value theorem. Now we're looking at the mean value theorem, because we're trying to guarantee a specific derivative on the interval. So what we need to do then is find the average rate of change on the interval. So we're going to be looking at h of 3 minus h of 1 all over 3 minus 1. And so we get that that is equal to, well, we just found those values up at the other problem. So negative 7 minus 3 all over 2. So we get negative 5. So the average rate of change over the interval is negative 5. And we're trying to guarantee that the instantaneous rate of change is negative 5. So since H is continuous and differentiable. Then by MVT, there exists a value C on the interval from 1 to 3 such that H prime of C is equal to -5. So remember, the conditions for MVT are that the function must be continuous and differentiable, and the average rate of change is what we can guarantee. And so we know H is continuous and differentiable because F and G are differentiable, and H is comprised of F and G. This one here was also worth 2 points. It was 1 point for getting that average rate of change, and then 1 point for your explanation and using the mean value theorem. All right, part C here. Let W be the function given by W of x is equal to the integral from 1 to g of x of f of t dt. Find the value of W prime of 3. Well, we can see that W is this accumulation function. So in order to find W prime of 3, we have to first find W prime of x, which means we're going to need to use the fundamental theorem of calculus. So W prime of x is going to equal the derivative of this integral. So we're going to plug in our upper bound. So we're going to get f of g of x times the derivative of that upper bound, so times g prime of x, minus plug in the lower bound, f of 1 times the derivative of the lower bound, which is 0. So that second part cancels out. You don't have to write it. I just wanted to write it so that you guys could see that fundamental theorem of calculus times g prime of x. So that's our w prime of x. So now to find w prime of 3, we're going to do f of g of 3 times g prime of 3. So we're going to do f of, let's see, g of 3 is 4 times g prime of 3, which is 2. So f of 4 is -1 times 2. So we get that w prime of 3 is equal to -2. For this one here, this was worth 2 points. So it was 1 point for finding that w prime of x and remembering to include that chain rule. That was really where the point came in. And then 1 point for your answer. And then in here on part D, we're given that g inverse is the inverse of the function g. Write an equation for the line tangent to the graph of y equals g inverse of x at x equals 2. So we're going to have to remember how to do the derivative of an inverse function. So first thing I'm going to do over here is I know that my inverse is y equals g inverse of x. And I know that I'm going to be looking at the point 2 something. I don't know that y value yet. But I do know that my original function is g. And I know that when I have an inverse function and an original function, my x and my y, my domain and range, flip. So if my input on the inverse is 2, that must mean that that's my output on my original function. So if I look at my function g, I want an output of 2. So here's all my output values for g of x, and I can see it has an output value of 2 at x equals 1. So I can right away then know that the point I'm looking at on my original is 1, 2, and the point I'm looking at on my inverse is 2, 1. And that's going to be important as we work through this problem. So I need an equation of a tangent line, which means I need a point and a slope. So I know that the point I'm going to use is the point on this inverse function, which is the point 2, 1. That's what we just figured out over there. Now we need the slope. So the slope of the tangent line is going to be the derivative, which means we're going to be looking at y inverse, which is really, or y prime, excuse me, which is really g inverse prime of x. And we're going to be looking at it not at x, but at 2, because that's the x value. But now this notation here is really weird. So we're going to look at how we did it in class before. So if we know that y is equal to g inverse of x, then before I do anything, the first thing I'm actually going to do is I'm going to do g of g inverse of x, and I'm going to do g of y. Because if I do that, then on the left side, I get g of y, and I'm going to make this function notation. So g of y of x is equal to x, because g and g inverse will cancel each other out. Well, now I can take the derivative of both sides. So I'm going to get g prime of y of x times the derivative of the inside, because I can't forget that chain rule. So y prime of x is equal to 1. And now, if I go back up here, I can solve for y prime of x, and it's going to be 1 over g prime of y of x. So if I want to find the slope at 2, I'm going to plug in 2. So y prime of 2 is going to be 1 over g prime of y of 2. Now the thing we have to remember is that that y that we're talking about is really this g inverse. So when we say y of 2, we're talking about this point right here. So let's see, that means then this is going to be 1 over g prime of 1. And if we look at our table then, g prime of 1 is equal to 5. So the slope that we're looking at is 1 over 5. So now we can write the equation of that tangent line. And it's going to be y minus 1 equals 1/5 x minus 2. So here's our tangent line. That's our final answer that we got there. I know that that gets a little confusing, especially with the notation and stuff. So if you have any questions, please make sure you reach out to your calculus teacher. This question was worth 3 points. So it was a point for figuring out what the point was that you needed to write your equation for. 1 point for your slope there, and then 1 point for your actual tangent line. All right, thanks, guys.